Good morning. Welcome back to my channel. Today, let's decode the core of DNA and RNA nucleotides. What is a purine and what is a pyrimidine, and why is CG bonding stronger than AT, and what's with a GAG in purine synthesis. And this isn't just theory, it is the kind of content that pops up in MCQs, pathology correlations, and even pharmacology. So grab your pen and let's decode nucleotides base by base. Okay, so moving on to the first question, a researcher is designing a DNA chain with high thermal stability. Which base pair should be maximized for this purpose? So, high thermal stability, it indicates CG bond. So, since it has three bonds and it is stronger than AT bond, so it'll have higher melting temperature. So, you can remember it by crazy glue. Moving on to the next question. A 5' triphosphate group is essential for nucleotide incorporation into growing DNA. Which part provides energy for this polymerization? So 5' end of incoming nucleotide, it bears the triphosphate bond. So phosphate bond, it provides the energy source for that bond. Which of the following best describes a nucleoside? So side, S for S, so base plus sugar. So nucleoside is base plus sugar and nucleotide is base plus sugar plus phosphate. A mutation prevents the methylation of uracil in a cell. Which nucleotide formation will be most affected? So methylation of uracil, it will lead to thymine. So there are more questions on this, we'll see it one by one. Which of the following distinguishes DNA from RNA structurally? So DNA has thymine and RNA has uracil. A biopsy reveals increased pyrimidine production. So which of the following molecules is not a pyrimidine? So you can remember it by purines ANG and cut the pyrimid CUT. It will be pyrimidines. How many rings are present in a purine structure? So A and G, adenine and guanine, so two rings. A child with an immunodeficiency is found to have a defective purine synthesis. Which of the following amino acids is not required for purine synthesis? You can remember it by GAG, glutamine, aspartate, and glycine. So it is given here. So glycine, aspartate, and glutamine. What is the correct base pair for pyrimidines? So as I've already said, CUT. Deamination of cytosine, it will form uracil. So it is given here. All the deamination reactions are given here. Cytosine, it will lead to uracil, and this is important. And 5-methyl cytosine, it will lead to thymine. Since thymine is a methylated uracil. Deamination of adenine, it leads to hypoxanthine. A patient has high uric acid due to purine degradation. Which deamination product contributes to this? So we'll see it in the next page that hypoxanthine, which is involved in purine degradation. So that will be the answer to this question. A mutation in the DNA part system fails to recognize uracil. So which enzyme normally prevents this incorporation? It is like among the given options, DNA ligase, DNA glycosylase, uracil DNA glycosylase, and DNA methyltransferase. So uracil DNA glycosylase. So we'll learn more about this enzyme glycosylase in base pair repair in the upcoming pages. Which of the following is formed by the deamination of guanine? So xanthine, it will be formed from guanine. Which amino acid is common to both purine and pyrimidine synthesis? So aspartate here, it is given here, it is both common to purine and pyrimidine synthesis. Which precursor contributes to the nitrogen to the purine ring and is also essential in the bionucleotide synthesis? So glutamine, it provides the nitrogen, contributes nitrogen to the purine ring, and it is essential in the purine synthesis. A patient has folate deficiency. Which pathway is likely impaired? Yeah, purine synthesis. So we'll learn more about this in the next page. which of the following increases DNA melting pressure? So as CG bond, so it has 3 bonds and hence it is stronger than 80 bond, it increases the melting pressure. Which component is absent in RNA but present in DNA? So hence it is a straightforward question, so it will be thymine. A mutation leads to hypomethylation in embryonic cells, which base stability is compromised both. I think so. Here is a line. Thymine has a methyl group, so it'll be here. They have mentioned it as hypomethylation. So the only pyrimidine with a methyl group is thymine. So hence the answer to this question is thymine. So that wraps up our breakdown of nucleotides. So if you found this page really helpful, and if you finally remember the difference between purines and pyrimidines, or if you just love how CG bonds are like crazy glue, then give us a like, share with your med buddies, and don't forget to subscribe to the G Factor. Coming up next, we'll explore the de novo synthesis pathways and the drugs that block them, from methotrexate to 5-FU. Until then, keep learning, keep questioning, and keep growing. Thank you.